Hey guys, so this will be the last video for our first unit of study. In this video we're going to talk about literal equations and then we'll talk a little bit about formulas. And just to define both of those things, a literal equation is going to be an equation that involves more than one variable. So all of these equations that we've seen so far have only had either an x in them or a y in them. A literal equation is going to be an equation that has two or more variables, and sometimes it's going to have all variables and no numbers. An example might be the equation y equals mx plus b. It's an equation, as you can see, it has four variables and no numbers whatsoever. A formula is a special type of literal equation that states a relationship among quantities. And oftentimes you'll find formulas in a physics class or a geometry class. One formula you should all know at this point is the formula P equals 2L plus 2W, which is the formula for perimeter of a rectangle. Perimeter equals 2 times length plus 2 times width. That's an example of a relationship among the quantities. It says if you take twice the length plus twice the width of any rectangle and add them together, then you get the perimeter. So just like we can solve regular equations for x, we can also solve literal equations and formulas. The only difference is we don't actually get a number for an answer. So none of the problems in this first set of examples here, for none of these you're going to get x equals 4, x equals 3. All we're going to be doing is rearranging or shuffling the variables in order to isolate a different variable. So for example 1 right here, we want to solve each of these equations for x. Now for this first example, there's actually a typo, so you actually need to, instead of having x equals 3y minus 4, rewrite this please as y equals 3x minus 4. That's what it should say. And so if we want to solve this equation for x, we simply need to pretend like y is just any old number, okay, like it's 2 or 3, and do what we would normally do, okay, to get x by itself. The first thing we would normally do, okay, in an equation like if y, let's say, was 2, if we had the equation 2 equals 3x minus 4, the first thing we would usually do is we would add 4 to both sides in order to isolate x. So we're going to do the same thing over here. We're going to add 4 to both sides of our equation. Those 4's are going to cancel. Now over here, I would have gotten 6 equals 3x had I added 4 to both sides. Over here though, I can't really add y and 4 because they're not like terms, so all I can do is write the expression y plus 4. And so that's how we're going to write that. The next thing I would do for an equation like this is I would divide by 3 in order to get x by itself. And so for this equation over here, that would have given me 2 equals x. Over here, I can still divide by 3, but again, I'm not going to get an actual number on this side. All I'm going to do is divide each part by 3. So that gives me y divided by 3 plus 4/3 is equal to x. And that's going to be my answer. Y over 3 plus 4/3 equals x would be this equation solved for x. Let's look at number 2, and we're going to do basically the same thing for this one. We want to solve for x, and so the first thing I need to do is, since we're subtracting 3 from both sides, I want to add 3 to both sides. So that's going to give me y plus 3 equals, I'm left over with a 4x, and now I just need to divide everything by 4. Remember that dividing by 4 is the same thing as multiplying by 1/4. So instead of writing y over 4, I could also rewrite this part as 1/4 times y, like this. And then I would have a plus 3/4 equals, those 4's would cancel, and so I just have an x. So that's what I mean by solving for a variable for a literal equation. You're not going to get just x equals one nice number. You're just reshuffling these variables and numbers around until you isolate the one you're looking for. Okay, for number 3, I have 2x minus 6y equals 14. So this time I have 2 variable terms on this left side here with the x. I want to get x all by itself, so just like the last problem, I'm going to get rid of subtraction first. In this case, I'm subtracting a 6y, so that means I need to add 6y to both sides. I just want to move that whole y term over the equal sign. So that's going to give me 2x is equal to 6y plus 14. Again, these aren't like terms, so I can't combine them at all. I just need to write it as the expression 6y plus 14. And now that allows me to divide everything by 2 in order to get the x by itself. So I can divide here, here, and here by 2, and that's going to give me this. X equals 6y divided by 2. The 6 and the 2 are going to cancel, and you're going to be left over with a 3y, plus 14 divided by 2 is just 7. So I get x equals 3y plus 7. For number 4, I have the equation ABC minus x over y equals m. And so I want to look at the term that has my x in it. That's the term I want to get by itself first. So what I'm going to do is, since I have a positive ABC here that I'm combining with this x over y, I'm going to subtract this entire term, ABC, in order to move it to the other side of the equation. And that's going to get the term with the x in it by itself. So that's going to leave me with, this is a negative x divided by y equals, I have m minus ABC over here. Okay, and now the next thing I can do, I want to get rid of this y, and I also want to get rid of this negative sign. So since I'm dividing by y, I can think of that as dividing by a negative y, and to get rid of division, we know we need to multiply. So I can multiply both sides of this equation by negative y. That's going to cancel out both my negative and my y down here. And now I just need to do that to this side as well. So that's going to leave me with an x on the left side. When I multiply by y on the right side, though, I need to remember that I'm multiplying a quantity, okay, by y, so I need to make sure I distribute this negative y. So that's going to give me this. It's going to give me negative my, and then I have a negative times a negative, so I'll get a positive here. And this will be written as ABCY. So we'll get x equals negative my plus ABCY. Okay, for number 5, I have the equation m minus h times x equals d. And so for this one, again, I want to get just the x by itself. So I'm going to get rid of the term that doesn't have an x in it, which would be the m first. It's a positive m, so I want to subtract m from both sides to move it. So if I subtract m, then I'm left over with this. This is a negative h times x equals, I'll just write this as d minus m on the right side. And then if I divide everything by this negative h, since it's negative h times x, that will get the x by itself. So now I'm going to get this. I'm going to get x equals, this will be a negative d over h, since I'm taking this positive d divided by negative h. And then I have a negative over a negative here, so that's going to give me a plus m over h. Okay, and then example 6 over here, I have x minus y all divided by a equals b times r. And so x in this case is in the numerator, and it's kind of sheltered away here by this a at the bottom. So this looks similar to an equation like this. We saw this back when we did two-step equation, something like x minus 4 over 2 equals 3. If you remember, in this case, I'm supposed to multiply by the denominator in order to get this numerator by itself. So in this case, like over here, I would have multiplied both sides by 2. For this problem here, I'm going to multiply both sides by a to get rid of this a in the denominator. So that's going to give me this. The quantity x minus y equals just ABR. And then what I can do is I can add y to both sides. So that's going to get x by itself, and I'm going to get x equals ABR plus y. Okay, so that's how to solve a literal equation for a variable. It's going to take some practice, I know, because the answers look kind of weird, but it's the exact same thing, just doing the opposite operation that you do when you're solving regular equations. Again, the only difference is you're not getting a number for an answer. Now, for these last few examples, we're going to use some formulas, and we're going to solve some small word problems using these formulas. So for each of these problems, it's going to be necessary for you to know some of your basic geometry formulas. And so in number 7 here, it's asking what is the radius of a circle with a circumference of 64 feet. For this one, you need to know the formula that involves radius and circumference of a circle. And so that formula is C equals 2 pi r. Circumference equals 2 times pi times radius. Make sure you know that formula. And so we're going to use that formula in order to solve this problem. So in this case, we know the circumference. We know the circumference is 64 feet. So I'm going to take this 64 feet here, and I'm going to substitute it in for C. And then my job is to find R. So we'll have this. We have 64 equals 2 times pi times R. I want to solve for R, so that means I need to divide both sides by 2 pi. Okay, so when I take 64 divided by 2, I end up getting a 32, so that's going to give me 32 divided by pi equals, you'll just have an R left over here. Okay, and so now I can get my calculator out and I can take 32 divided by pi. Now your calculator actually does have a pi symbol, so I don't have to use 3.14. I can just plug in pi to my calculator. If you go to the very bottom of your keypad, right next to the letter H, you should see a pi symbol. If you click that, it's going to bring up a menu, and you should see the box pi. You just want to go ahead and highlight that, and then do 32 divided by pi on your calculator. And if you do that, you end up getting a fraction, 32 over pi. But then remember, if you hit Control Divide again, that will turn that into a decimal. So after you do 32 divided by pi, hit Control and then Control Enter. After you do 32 divided by pi, hit Control and then Enter, and you should get R equals approximately 10.2. We'll go ahead and we'll go to the nearest tenth for these. So we can say the radius is about 10.2 feet. Okay, let's look at number 8 now. It's asking what is the height of a triangle that has an area of 24 square inches with a base length of 8 inches. And so for this one, we need to know the formula that involves triangles, their height, area, and base. And so that formula is going to be A area equals 1/2 times base times height. So for this problem, I'm trying to find the height. I'm given the base. I know the base is 8 inches long. I'm also given the area. The area is 24 square inches. So I'm going to plug those two numbers in and solve this for h. So I'm going to have the following equation. 24 is equal to 1/2 times my base, which is again is 8, times h. And so to solve this equation, I'm going to simplify my right side first. Half of 8 is 4, and so I have 24 equals 4h over here. Then I can divide both sides by 4, and I get an answer of 6. So that means that the height of this triangle is 6 inches. Okay, for the last example, I'm trying to find the length of a rectangle with an area of 94 square inches and a width of 7 inches. And so you need to know the formula for area of a rectangle. That would be area equals length times width. And so for this one, I'm given two things. I'm given the area. I know the area is 98 square inches. And I'm given the width, which is 7 inches. And I just need to find the length. So I'm going to set up my equation as 98 equals L times 7. And if I just divide both sides by 7, that's going to give me the length. 98 divided by 7 is 14. And so that means the length of this rectangle is 14 inches. Okay, so feel free to go back and pause and rewind anything you need to as far as the examples in this video. We'll discuss this in class the next time I see you. Until then, have a nice day. You're all wonderful people.